In this video, we'll take a look at the James Webb Space Telescope's discovery of the birth of the first ever star. The James Webb Space Telescope has captured an hourglass of light around a young star. This star is still forming and has a disk of debris that could eventually become planets. This star is being born 450 light-years away in a star-forming region known as Taurus. L1527 is the name given to the dark cloud of dust and gas that surrounds it. The protostar has been around for 100,000 years. Does that sound old? It is not, in fact. In the early stages of star formation, the star will continue to compress under its own gravitational pull for the next million years in order to become a fully formed star. The Milky Way galaxy alone contains approximately 400 billion stars. The star is encased in a disk of dust and gas in the new image captured by JWST, which provides fodder to the star as it grows. It may eventually result in the formation of a solar system. The protoplanetary disk, which is the same size as our solar system, is located in the center of the image. According to New Scientist, this is represented by a straight line across the hourglass's neck. The shining light emanating from the star is what we see above and below it, giving it the shape of an hourglass. The image is now visible to us thanks to JWST's powerful capabilities. Otherwise, such cosmic entities are invisible to the naked human eye in infrared wavelengths. The bright clouds visible in the image are the result of material ejected by the protostar. This exercise causes turbulence in the surrounding region in order to prevent the formation of other stars in the baby star's immediate vicinity. By observing such phenomena, scientists hope to gain a better understanding of how stars form. One of the first images taken by the James Webb Space Telescope shows one of the most ancient stars ever seen. Researchers report in the October 1st issue of Astrophysical Journal Letters that the stars, which formed around 800 million years after the Big Bang, live in tight groups known as globular clusters, and encircle a distant galaxy known as the sparkler. Globular clusters frequently contain some of the oldest stars in modern galaxies, such as our own, but pinpointing their precise age is difficult. The new discovery could help scientists figure out when such clusters first appeared. Globular clusters are small compared to galaxies, making them difficult to see from afar. However, a massive natural lens in space came in handy this time. The sparkler is one of millions of galaxies that lurk far behind SMACS 0723, a massive, much closer galaxy cluster that served as the basis for the first publicly released science image from the James Webb Space Telescope. Space-time is twisted by the cluster, magnifying the light from distant galaxies behind it. The increased magnification reveals previously unseen details in all of those distant galaxies. Lamia Mola and her colleagues were drawn to a long, yellowish, blotched galaxy. When we first saw it, we noticed all those little dots around it that we call the sparkles, says Mola of the University of Toronto. The researchers wondered if the sparkles were globular clusters, which are thought to be close-knit families of stars born together and stay close to each other throughout their lives. The unanswered question is how the globular cluster themselves were created. Mola elaborates. Were they born at cosmic noon 10 billion years ago, when star formation exploded throughout the universe, or did they form 13 billion years ago, at the cosmic beginning, when stars could form for the first time? Light from the sparkler takes approximately 9 billion years to reach Earth. So if the sparkles are globular clusters that blazed that long ago, they could aid astronomers in determining the answer. Mola and her colleagues investigated the wavelengths of light emitted by sparkles using JWST data. Some of the clusters appear to be producing stars at the time their light left the clusters. Some, on the other hand, had long ago formed all of their stars. Light from the sparkler takes approximately 9 billion years to reach Earth. So if the sparkles are globular clusters that blazed that long ago, they could aid astronomers in determining the answer. When we see them, the stars are already about 4 billion years old, says Karthik Iyer, an astrophysicist at the University of Toronto. This suggests that the first stars in the sparkles may have formed around 13 billion years ago. There's only a short amount of time after the Big Bang when these could have formed, he says, referring to the universe's age of 13.8 billion years. In other words, these clusters formed at dawn rather than noon. More research on globular clusters around ancient galaxies could help determine whether such clusters are common or uncommon in the early universe. They may be useful in understanding the formation history of galaxies, according to Mola and Iyer. Their team has presented observations that could help JWST achieve this goal in its first year, according to Stockholm University astronomer Adelaide Claessens. Picking out very small formations like globular clusters from such a great distance was nearly impossible before JWST. She was not involved in the latest study, but earlier this year she led a comparable analysis of numerous galaxies amplified by the SMACS 0723 cluster. It's the first time we demonstrated that, with James Webb, we'll see a lot of these types of galaxies with really tiny structures, Claessens says. James Webb is going to be a game changer in this field. It's a good time to take a breather and appreciate our first-class ticket to the depths of the universe, as well as how these images allow us to travel back in time. Looking back in time may seem strange, but it's something that space scientists do every day. The rules of physics govern our universe. And one of the most well-known rules is the speed of light. And when we say light, we mean all the wavelengths in the electromagnetic spectrum, which travel at a whopping 300,000 kilometers per second. Light travels so quickly that it appears to be instantaneous in our everyday lives. Even at these breakneck speeds, traveling anywhere in the universe takes time. When you look at the moon, you see it exactly as it was 1.3 seconds before. It's only a small window into the past. But it's still the past. Our galaxy, the Milky Way, is 100,000 light-years across, and the stunning newborn stars visible in JWST's Carina Nebula image are located 7,500 light-years away. In other words, the nebula depicted here dates from roughly 2,000 years before the invention of writing, which is thought to have occurred in ancient Mesopotamia. When we turn our gaze away from the Earth, we are looking back in time to how things were. This is a superpower for astronomers because we can use light as it has been observed throughout history to try to solve the mystery of our universe. Certain wavelengths of light that are unable to pass through Earth's dense atmosphere can now be seen using space-based telescopes. The Hubble Space Telescope was designed and optimized to use both ultraviolet and visible wavelengths of light. The JWST was designed to use a wide spectrum of infrared light. This is one of the primary reasons the JWST can see further back in time than Hubble. Galaxies emit a wide range of electromagnetic wavelengths, from gamma rays to radio waves and everything in between. All of these provide important information about the various physics that occur in a galaxy. When galaxies are close to us, their light hasn't changed much since it was emitted, and we can probe a wide range of wavelengths to learn more about what's going on inside them. We no longer have that luxury when galaxies are extremely distant. The light from the most distant galaxies has been stretched to longer and redder wavelengths as the universe has expanded. This means that some of the light that was visible to our eyes when it was first emitted has since lost energy due to the expansion of the universe. It is now in an entirely different part of the electromagnetic spectrum. This is referred to as cosmological redshift. We live in an amazing technological era. We had no idea there were galaxies beyond our own just 100 years ago. We now estimate trillions, and we are spoiled for choice. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this. We'll see you with another interesting video.